Good morning. Here is the video for our next set of notes, the 10E notes here. So we think back to our previous unit on exponential functions. The parent exponential function is y equals 2 to the x power. Okay, y equals 2 to the x power. We did that back in unit 9. All right. So if we were to graph this thing here, we have our x's and our y's, and so we're going to take x will go -2, -1, 0, 1, 2, 3. If we were to do this up here, if x is -2, y would be 1/4. If x was -1, y would be 1/2. If x was 0, y was 1. If x was 1, y was 2. 2 to the second power is 4. 2 to the third power is 8. And so on and so forth. So we're to graph this thing here. So we have -2, 1/4, -1, 1/2, and then 0, 1, and then 1, 2. Then we have 2, 4, 3, 8. All right. So we see our parent exponential function is going to kind of look something like this. All right. And as you know, it would kind of level off going down here. It would never get equal to 0, no matter how negative the x values would go. So this graph had a y-intercept at 0. We had a horizontal asymptote at y equals 0, which is also the x-axis. All right. The domain was all real numbers. All right, and the range was y is going to be greater than 0. Not greater than or equal to 0. It would just be greater than 0 because, again, it never touches 0. Gets infinitely close, but it's an asymptote, never hits 0. Okay? This is the exponential function, parent exponential function. Now, going back to what we talked about very early in the year, if we had a function and we were to write the inverse of that function, what you do is you flip all the x and y values in the equation, as well as the individual points. Okay, so the inverse of the parent exponential function would really be x is equal to 2 to the y power. I don't know why this is all here. Okay, because the original exponential function is y is equal to 2 to the x power. And so the flip of that is x is equal to 2 to the y power. Okay. Now, in order to get the y by itself, we rewrite this as a logarithmic equation. Okay. Again, we write a logarithmic equation when the variable that we're looking for is the exponent. Okay. And writing that as an exponent is going to be y equals log base 2 of x. All right. So this function x being equal to 2y says the same thing as y equals log base of 2 of x. Okay. So coming back to our original one here, we had y equals 2 to the x power. All right, so we had our points -2, -1, 0, 1, 2, 3. So we had -2, 1/4. Whoops. So we had -2, 1/4. We had 1, 1/2, 0, 1, 1, 2, 2, 4, 3, 8. So to redraw this thing here, we had this here, 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 here. All right, that's the one that we had before. That's our exponential. So that's our y equals 2 to the x power. The inverse function, y equals log base 2 of x, we're just going to flip all that. Okay, so we could just flip our x's and our y values here. So if x is 1/4, y is -2. If x is 1/2, y is -1. If x is 1, then y is 0. If x is 2, y is 1. X is 4, y is 2. And if x is 8, y is 3. Okay? Again, that's the inverse function right there. And you just flip the x's and y's from here. So if x is 1/4, y is -2. X is 1/2, y is -1. And then we have 1, 0. And we have 2, 1, 4, 2, 8, 3. Now, interestingly enough, we have a horizontal asymptote here on our exponential. So what's going to happen is we're actually going to have a vertical asymptote here on the inverse, because again, these things are just sort of reflections of each other. Okay, so this function right here is going to be y is log base 2 of x. Okay, it's going to look something like that. So we flip all of our x and y values from the exponential function in order to get the logarithmic function, and we sort of did that over here in comparison to our original logarithmic function that we did over here in pink. And so what we see with our asymptotes here is now, okay, on the original one, the exponential, we had a horizontal asymptote at y equals 0. Now we're going to have a vertical asymptote at x equals 0, which is also the y-axis. Okay. In addition, when we think of our domain and our range, well, our domain and our range are going to flip from the other one. So here on this one, the domain, x is going to have to be greater than 0. It'll never be 0 or less. Okay, because you can't raise 2 to any power to get a number that's 0 or lower. It's impossible to do that. Okay, we can get numbers that are infinitely small, but we're never going to get to 0. All right, we're going to see the range. The range is going to be all real numbers. Okay, we go down forever, we go up forever. I mean, it's going to take a while to go up, but the range is all real numbers. Just the opposite of what we had on the inverse function up here. On the inverse function, the pink one, we had a domain of all real numbers, but the range was y being greater than 0. Okay, so all that stuff just flips. And that's just the rule with inverse functions as they are. It's just a rule. Okay, so that's our parent logarithmic function here, y equals log base 2 of x. And so hopefully we have that down and we kind of see what this function sort of looks like. We have a vertical asymptote, x equals 0, domain, x is greater than 0, range is all real numbers. And we also see that here we're going to have a x-intercept of 1. Right, we have an x-intercept of 1. On the exponential, we had a y-intercept of 1. On the logarithmic, we have an x-intercept of 1. Okay, total flip from what we had up here. All right, so underneath here, we just have identify the transformations. So same rule that we have of transformations. We could have vertical stretches, vertical compressions, horizontal stretch, horizontal compressions, horizontal reflections, vertical reflections, and then any kind of translation up, down, left to right. So you can use Desmos to graph the original log base 2 of x and then just manipulate it as you see fit there to identify the transformations here. And that's what we have on these notes here. Later on, we'll talk about making a table and sketching the functions of e to the x power and the natural log of x, and 10 to the x power and log base 10 of x, which are also inverses of each other. They're going to look a little bit different from this one. This is what I just wanted to focus on right now. A lot of carryover on this from the previous unit because, again, logarithms are just when we have variable exponents. So these kind of go together there. So take some time and do the transformations on the next page. And that is it for the 10E notes for right now. And we will take care of the other stuff at a later date. Y'all have a good day.